In this lesson, we'll explore shell scripting. The bash shell program that you have been working with for this entire semester when you log into your container is a command line interface that you were able to type commands into. And it's actually a running program. There's a program at the directory, in the bin directory named bash, and this is the program that starts up as you begin a session in your container. If we were to look at the manual for this program, we would see that it's an SH compatible command language. I'll talk about what SH is in just a moment. And it specifically lists two important things. It says it either executes commands read from standard input, right? So these are the ones that we're typing into our keyboard, and when we press enter, those textual characters are sent over standard input to the bash program or from a file. And that's what a shell script is. We're going to be able to write files that have commands written in those files that the bash shell program can then read and move through those commands that are saved in a file one after the other, right? And so what it gives us the ability to do is script a sequence of commands, or you could think of them as small programs, and we often call these simply scripts, that compose many commands together to achieve some larger task that might become repetitive or redundant. So what's this language about an SH compatible command language? Well, SH was short for shell, and that was the original Unix shell program of the 70s and 80s. Bash came along in the late 80s and really took over in the 90s as a de facto shell. Today, there are other shells that you could use. Fish and ZSH are two other common ones. Mac OS just moved over to ZSH, or the Z shell. But Fish is also a really cool one, and I would encourage you to explore playing with those if you have interest in other shell command languages. So what's the big deal about a shell script? Well, I kind of hinted at this, but it allows us to combine many commands into a single file that we can then rerun in one pass in a single go as if it were a program. We'll see that scripts can not only have commands, but they'll be able to have variables, branched logic, so we can have if-else statements in them. We can have loops, and we can even define functions in our scripts as well. They allow us to automate common tasks that we would otherwise have to perform manually at a command line, such as things you want to run every time you log in to your machine, or steps that are part of the build process in making a project, or if you needed to data scrape some data from a website or process some data in a pipeline. Scripts are commonly used in labs to run through a sequence of steps to clean up some data, bring data together, and then actually generate outputs of graphs and charts and things like that. It's also used and useful for writing scripts to back up data. If there are common files that you want to save out to somewhere else other than your computer, you can write a script to do that, and that's common in industry as well. Another thing that we'll get some exposure to today is we can write a script to put a facade over programs that have specific use cases, that have common command line arguments, all right, and there might have many command line arguments. So what is a facade? Well, this is the idea that sometimes programs expose a lot of different options, right? You've got in some ways, a program and the command line might be a Swiss Army knife that has many different functionalities, but you really want to use it for one specific purpose. So what a facade would do is it would be a script that allows you to transform your use case into something very simple that then makes use of the more complex and intricate arguments of some Swiss Army knife type application. So for example, Pandoc is a program that allows you to convert markdown files to PDF files, right? And there's this -O flag that you have to remember that you're trying to change the name of some, the output file is going to be some name.pdf. And notice there's this duplication of name. And if this was a common pattern we used, we might be able to write a facade script that would allow us to run and name the facade script MD2PDF and just give a name such that we wouldn't have to worry about the markdown extension or the PDF extension. And what all this facade script would do is just translate this command into the one that you see above it. Right? So that's the idea of a facade, and we'll work with that later in today's materials. So what I would like you to try doing is following through these steps in your container. We're going to make a practice directory named shell scripts. And in that directory, you're going to work on your very first shell script named hello world. Add the contents that you see in this slide, save, quit Vim, and then try running bash followed by hello world and observing the output. Once you've done so, go ahead and respond on Gradescope to a few questions related to this exercise. Okay, so you should have seen some output that looks like what I'm seeing on my screen. And if we look at this simple shell script, we'll notice that we've got a variable that we're setting up and we're running some echo commands. And we'll talk about the syntax that we're seeing for these strings that follow echo in just a moment. Right? Now, one of the first things I want you to try is not only running just bash hello world, but try giving some arguments after hello world. So bash hello world and maybe foo and bar. And notice that we get some additional information in our output from this shell script, right? So this number variable, we'll see that this is the number of arguments we passed to our script. So the script was hello world and foo and bar were arguments that were passed to it as a part of running this command. We can see that the at operator, or sorry, not the at operator, the at variable is going to have the contents of all of our variables here that were passed in as arguments. And then we can access specific variables by their numerical order in the argument list, right? So argument 1 was foo, argument 2 would be bar, so on and so forth. So we could prove to ourselves that this works with another example, say with just bar, and notice that we have one argument. All of the arguments are just bar itself, and then there's the first argument, which is also going to be bar. Okay, so these are special variables that are set up, and we're about to talk about how we can use those variables. You already have some hint at this, though, right? Because if we looked at us assigning to a variable named target, which this feels like an assignment statement you would write in any other programming language, and in our echo, notice that we are referencing target here such that when we go and see, well, what was the output of this? It was hello world. So what this syntax must be doing is substituting the value of target into this string. So let's talk about variables in string interpolation. Anytime you make an assignment statement in a bash script, you're either initializing a variable if it's the very first time you've assigned to it, or you're reassigning a new value to it. Typically, the values that you assign to the variables that you use are going to be of type string because we're working in a textual command line interface. Textual data and string data is the most valuable that you'll wind up working with and will make up almost all of the variable usage that you'll encounter. String interpolation is this idea that we can take a string literal, such as what we're seeing here, and before the command line interpreter sends this string value off to some program, what it's going to do is substitute any interpolation syntax that needs to be evaluated. So here we see this dollar symbol is a hint that, hey, we're about to interpolate a value into the string here. We're going to substitute a value. And these curly braces are surrounding the name of a variable. And this is saying, hey, a variable is, and then read a variable's value into this location in the string and replace it. We're going to encourage you to use double quotes around string interpolation anywhere you are making substituted use of variables. This is the safest way to go about using string variables in a bash script. And we're always going to have this convention in this course, and I would encourage you to carry it out into the real world of anytime we want to reference a variable or read a variable's value in some other command, we're going to have it somewhere in double quotes and then use this dollar symbol and curly brace syntax to get at it. There are other ways that we can access variables. In fact, there are slightly less verbose ways of doing it, but those ways come with trade-offs of potentially opening your script up to vulnerabilities or some unexpected behavior if you're not careful about how the rules of substitution work when you don't use double quotes. But if you stick to a rule of thumb of always using double quotes and always accessing your variable with a $ followed by some curly braces and the variable's name in between those curly braces, you don't have to remember any of those special rules. This will just always work the way that you would expect it to. When we ran the command bash hello world, we saw that there were some special variables set up and whose values were automatically pre-populated for us if we gave additional arguments, such as go and heels. What's happening here is the bash script is evaluating hello world. It's reading that file, and it's setting up some special argument variables that are going to be addressed or accessible inside of the hello world script. So go would be accessible via the $ and then the variable named the number 1, and heels would be accessible in the variable named number 2. There's another variable that's 0, and that would actually have hello world in it. It's the path to the script that got executed. And you could try playing with that if you want to pause the video and try printing out the 0 value variable in the hello world script we just ran. There's another special variable which we saw, which was the @ symbol, and it holds all of the arguments space separated. And we'll see where we might use that in a future part of the lesson. Bash scripts can have comments. So a comment in bash begins with a hash symbol. The hash symbol must be preceded by a leading space though. So if you had echo hello followed by a space and then a hash and then some comment, and anything that comes after the comment hash is going to be ignored, right? So I could have had a trailing space here, but I wanted to make it very clear that what's required is a leading space before the hash. If we didn't have a leading space, this wouldn't be a valid comment. And the reason for this is bash is going to treat this first value as a string that's just unquoted. And it would try and pass to hello hash this, right? So it doesn't know that this is the end of some piece of some argument. And to make sure that it is able to interpret that correctly, you need a leading space. This text is going to be ignored like a comment in any other language you've used.